Hello and welcome to this demo on managing difficult situations in which reliable selectors aren't automatically identified in the studio. In this demo, we'll learn how to use the anchor base, the relative selector, the visual tree hierarchy, and the find children methods to improve the reliability of a selector. Selectors are one of the core features of UiPath Studio, and they may be a bit challenging to understand at first. One of the difficulties is that the selectors must be specific and generic at the same time. To be precise, selectors should be specific enough to uniquely identify interface elements, but also generic enough to work even if there are a few changes on the screen or if there are a series of items being processed. Let's consider a use case for our demo. Here, the position of the input field changes every time we click the Submit button. To demonstrate this use case, we'll use the RPA Challenge website. Okay, let's begin. We already have a simple workflow created. Let's also ensure that we have the RPA Challenge website opened in the Edge browser. The purpose of our main.xaml workflow is to highlight the first name text box on the RPA Challenge webpage. To check that our selector is reliable, the robot will loop through highlighting the text box and clicking Submit 5 times. It uses the index variable to keep the count. So, how can we start assessing the reliability of our selector? We'll open UI Explorer and indicate the first name field from the RPA Challenge website. The selector generated by this activity uses a tag and ID to identify the element. The clue that the generated selector might not be good enough is that it contains an ID attribute. This ID is a random string of characters and is dynamically generated. Hence, it changes every time the web page is refreshed. We can tackle this problem in different ways. Let's have a look at a few of these approaches. We'll use the same example for all of our approaches. Our first approach is the anchor base activity. We've created a separate workflow file for this, anchorbase.xaml. Let's open it. It's important to understand how this activity works. Anchorbase uses a stable element, let's say a field label, to perform an operation on a less stable, related element. In our example, the less stable element is the first name text field. The anchor sets a starting point on the screen and looks for a match in a specified direction. Let's add an anchor base activity to the workflow. This activity supports 2 activities for the anchor section: find element and find image. For this example, we'll use the find element activity. This activity waits for a specified UI element to appear on the screen and returns the element as a UI element variable. Let's add it to the anchor section. Next, we'll indicate the first name label on the website as the anchor element. Moving on, we'll drag a highlight activity inside the action section and indicate the first name text box. Let's save the project. Now to run the workflow, we'll invoke the anchorbase.xaml from the main workflow and click Run File. Great, we can see that the workflow is executed as expected, even though the text fields change every time the page refreshes. And this concludes our first approach in which we use the find element activity as an anchor to stabilize the selector. Now let's look at the second approach, the relative selector approach, where we stabilize the selector using anchors selector from the UI Explorer. We begin by adding a highlight activity and indicating the first name text field on the RPA Challenge website. Now we'll edit the selector by going to the UI Explorer. Here, we'll indicate anchor, and we'll select the first name label as an anchor element to our target. The selector that's generated isn't good enough. It still relies on the dynamic ID attribute to identify the target element. So we'll uncheck the ID option and validate the selector. Our selector is valid and ready to be used for the highlight activity. Let's save the changes. Okay, it's time to run our workflow. Let's save the workflow, invoke this from the main workflow, and click Run File. As we can see, it works. This concludes our second approach in which we can improve the selector by creating a relative selector using UI Explorer. Now let's explore our third approach called the Visual Tree method. In this method, we stabilize the selector by including the tags and attributes of a UI element that is above in the hierarchy. Let's open this workflow. As before, we'll begin by adding a highlight activity and indicating the first name text field. Now we'll edit the selector by going to the UI Explorer. This method requires some analysis in the UI tree. We see that the input field is under a div container together with label. Under closer inspection of the div container, we notice that the first name label is present under the inner text attribute. This will enable us to construct a more reliable selector. Inside the div container, we'll select the input field where the entire UI tree is highlighted. Let's remove the ID attribute. Next, we need to activate our target attribute. To do this, we'll activate the parent node and enable the inner text attribute from the right-hand side. This results in generating a reliable selector for our activity. Let's validate and save it. And let's save the workflow. And we're done. We'll go back to the main workflow, invoke visualtree.xaml, and run the project again. Great, it works. This concludes our third approach in which we can improve the selector by configuring a better path in the UI tree. So far, we've seen three methods in which we can improve a selector and find ways to identify the element on the screen. In some rare cases, these three methods aren't enough, and we need to do something even more specific. It's time to find out how we can use the activity called Find Children. This method works by using the Find Children activity to target a reliable container and return all of the child UI elements of that container. To see it in action, let's open the findchildren.xaml workflow. Let's also add a Find Children activity. Now let's go to UI Explorer, click Indicate Element, and select the First Name text box. We'll click div container, which is a parent container to the UI element that we want to target. We'll enable the inner text attribute from the right-hand side. Validate and highlight. We'll notice that it highlights both the first name label and the first name text box. The selector looks stable. Let's copy it. We'll return to the UiPath Studio. For the Find Children activity, we'll indicate on screen the first name label just to replace the generated selector with the one that we've copied earlier. The output of this activity is a collection of all of the UI element children that are identified inside the defined scope. We'll create a new variable called children to store the output of the activity, and we'll change the scope from find_children to find_descendants. This way, the activity will iterate through nested containers. If we were to have another container inside of the parent container and the input field some levels deeper, we could still find it. With the find_children scope, we'd only get the top level. The children variable is a collection of UI elements. We'll iterate through it using the forEach activity. We'll call the iterator element. The type argument will be UI element, and we'll set children as the input variable. When configuring the highlight activity, note that our input isn't a selector. What we have is an element from the children collection. To be precise, an object of UI element type referenced by the element iterator. This means that instead of using the selector property, we'll add the element iterator to the element property. For any given UI automation activity, the selector and element properties both cannot be filled in at the same time. Only one or the other can be used to identify an element. Moving on, if we highlight all of the elements in the collection, we'll get both the first name label and the text box as well. To solve this, we'll use an if statement to identify the input field. We'll add an if statement activity and enter the expression element.getFriendlyName.contains open brackets, open quotes, input, close quotes, close brackets. Next, we'll move the highlight activity inside the then block. Let's save and run the project from the main by invoking the workflow. Great, it works. This concludes our last approach in which we use the Find Children activity and return all of the child UI elements of that container. For a quick recap, in some situations, identifying a UI element reliably may require more advanced techniques. In this video, we've demonstrated the anchor base, relative selectors, visual tree, and Find Children methods. Anchor base uses a stable element to perform an operation on a less stable, related element. Relative selectors work in an equivalent way and are generated by clicking Indicate Anchor in UI Explorer. The visual tree method entails analyzing the target element and the parent nodes in UI Explorer to identify a combination of attributes which makes the selector more reliable. Find Children lets us indicate a stable container and retrieve its child UI elements as a collection. We can iterate through the result and filter for the elements that we want. UI automation activity can either use a selector of type string in the selector property or an object of type UI element in the element property, but not both, to identify a target. Whenever you encounter a difficult situation, such as using dynamic web pages where the reliable selectors can't be identified automatically, think of all of these possible approaches and apply the appropriate one. Thank you for watching, and until next time, happy automation!